Hello everybody. I'd like to work through a cubic equation, and the main goal will be to solve for x, basically find the roots of the cubic polynomial. So let's consider this polynomial over here. I just write p of x for polynomial, but I mean it could be called anything. So to find the roots, we need to set this polynomial equal to 0. So we should get 3 solutions since this is a cubic function. Highest power is 3, so that means there should be 3 solutions. So ideally we want p of x to be expressed in the form of, let's say, x minus r1 multiplied by x minus r2 multiplied by x minus r3, where r1, r2, and r3 are the roots. And just to be specific, we're only working with real values yet, so x is real. Maybe I should mention that we're just dealing with the real numbers, so no imaginary answers. So the cubic polynomial in its most general form is expressed as ax cubed plus bx squared plus cx plus d is equal to 0. Now, we'll call a the leading coefficient. Often we can just call it the leading coefficient because it's the coefficient of the, and I must just emphasize that a can't be 0, because if a is 0 then this is quadratic. So we just call this the leading coefficient, and then generally we'll call d just the constant. So this is the value or the term in the expression that doesn't have an x, it's not multiplied with an x. So this, when we solve for these cubic polynomials, our first step is to make a guess. We have to guess the one root, or at least one root. So step 1, guess a root. I'll put it in inverted commas. Guess a root. Now, obviously there are infinitely many real numbers, so where do we begin guessing? So there's something called the rational roots test. And what this says we can do, or at least it will help, it's not guaranteed, but it can help, rational roots test, is that basically consider factors of the constant term, which is d, over the leading coefficient a. Let me maybe write it as constant over leading coefficient. And we must consider plus or minus of these. So this can at least help us make some educated guesses. So if we look at our example, let me write it out here. So we've got p of x is equal to x cubed plus 2x squared minus 5x minus 6. So in this term, if we set p of x is equal to 0, so let's make this 0. This is our constant, negative 6, and our leading coefficient here is 1. So we should consider factors of 6 over 1. So factors of 6 over 1, 6 over 1. Well, I'll say plus or minus because we're going to consider both. So what are these factors? Well, so obviously it's 1, negative 1, 2 and 3 are also factors of 6. So 2, negative 2, 3, negative 3, 6, and negative 6. So we're going to literally have to plug these in one by one and hope that one of them equals 0. So let's try p of 1 and see what we get. So if we plug p of 1 in, we get 1 cubed plus 2 times 1 squared minus 5 times 1 minus 6. And what is this equal to? So this gives us 1 plus 2 minus 5 minus 6, which is equal to 1 plus 2 is 3, 3 minus 5 is minus 2, and minus 2 minus 6 is minus 8. and this is not 0. So 1 is not a root. So now let's try the next value in our list. So let's try x is -1. So p of -1 is equal to -1 cubed plus 2 times -1 squared minus 5 times -1 minus 6. And let's see what this gives us. So -1 cubed is just -1. 2 times -1 squared. So -1 squared is just +1. So 2 plus +1. 2 times +1 is just 2. So this is +2. Minus 5 times -1 is +5. And then minus 6. And let's see what we get. Well, -1 plus 2 is 1. 1 plus 5 is 6. And 6 minus 6 is 0. So now we're very happy. We managed to find the root. So therefore, x is equal to -1 is a root, or a 0 of the polynomial. And what this means is x plus 1 is a factor. Is a factor of p of x. This means it divides p of x. So this means that we can write our polynomial p of x is equal to x plus 1 multiplied by some quadratic polynomial. It has to be quadratic because we need a cubic solution. So the x in here will multiply by an x squared in this quadratic, which will give us an x cubed. So there are 3 methods we're going to look at now to solve, how to find out what this quadratic is. There are 3 ways. The first one, let me just say which 3 we're going to look at. I'm going to look at inspection, which is use inspection. I'm going to look at long division, well, I'll say polynomial long division. Polynomial long division. And then the third step, and this one was popular when I was in high school, is synthetic division. Now you can use whichever one you want. Naturally go with the one that's fastest, especially in an exam or test. So inspection says, well, we've got p of x. We know that it is x cubed plus 2x squared minus 5x minus 6. And now from the fact that x plus 1 is a factor, we know that this is equal to x plus 1 times some quadratic. Now what is that quadratic? We don't know, so we're just going to write it in a general form. So we'll write it as ax squared plus bx plus c. Now I'm just writing these as, I don't know what happened there. I'm writing them as capital letters so we don't confuse things. So let's literally just expand this and see what happens. So if we do x times ax squared, we get ax cubed. X times bx gives us bx squared. X times c gives us positive cx. And then we just use the 1 and multiply, so we just get the same, multiply by 1, we get the same thing. So it's ax squared plus bx plus c. Now let's group the like terms. So there's only one x cubed, so it's just ax cubed. X squared has an a and a b there, so it's plus b plus a x squared. The x to the power 1 there has c and b, so c plus b times x. And then the constant term here is just plus c. And now we literally just equate. That's why it's called inspection. We're just gonna do an inspection. So let's just write the equation here. So for x cubed, the coefficients of x cubed, this is a 1, remember, so we've got a is equal to 1. And then for x squared, this is 2 from our main polynomial, so we've got, and this here is b plus a, so we've got b plus a is equal to 2. And then for our normal, just x to the power 1, in our original polynomial it's -5, here it's c plus b, so we've got c plus b is equal to -5. And then of course the constant is just c is equal to negative 6. So if you look at this here, we already have two of our three missing variables. We've got a is equal to 1, and we've got c is equal to negative 6. So we just need to solve for b, and we can take any of them. So b plus a is equal to 2. This means b is equal to 2 minus a, and a is 1, so this is 2 minus 1, which is equal to 1, so b is 1. So I'll just write it here, therefore b is 1. So that means our quadratic, if we go back to our quadratic there, is, so let me just do this, so ax squared plus bx plus c is equal to a is 1, so just x squared, b is 1, so just x, and c is negative 6. P of x is x plus 1, which was the first factor which we managed to guess, multiplied by x squared plus x minus 6. So we're still not done. We want to factorize our quadratic now. Now this one happens to be reasonable. We don't have to use the quadratic formula. We see that this is a negative 6, and our middle term is a positive 1x. So we need our factors of negative 6. Factors of negative 6 are, let's see, factors of negative 6 are, I suppose, negative 1 times 6, 1 times negative 6, negative 2 times 3, 2 times negative 3. So we need to pick factors here that when added give us this middle term for plus x plus 1x. So that would be 3 and negative 2. Positive 3 plus negative 2 gives us positive 1. So our quadratic here, x squared plus x minus 6, can be factorized into x minus 2 multiplied by x plus 3. So all in all, we've got p of x is equal to x plus 1 multiplied by x minus 2 multiplied by x plus 3. And now we've got all three of our roots. The roots are x is equal to negative 1, x is equal to positive 2, and x is equal to negative 3. If this were a graph and we're plotting it, these 3 points would be on the x-axis. So let's look at another way to solve this problem. Let's do polynomial long division. So we expect to get the same, obviously we must get the same answers. Now, long division was normally taught to us in the early years of school, but just with numbers. Now we have to do it with polynomials. So here we take our factor that we guessed, which was x plus 1. I'm going to put it in brackets. And we want to use it as the divisor of our full polynomial, which is x cubed plus 2x squared minus 5x minus 6. So what we do is we consider the variable x. So we ask ourselves, how many times does x go into x cubed? Well, x squared times. And then we take x squared and we multiply it by this entire factor. This gives us x cubed plus 1x squared. I'll put the 1 there even though we don't normally. And now we minus this, we subtract this. So the x cubed minus x cubed, that's 0. So that's good, that's what we hope to achieve. And then 2x squared minus 1x squared is just 1x squared. And then, like typical long division, we bring down the next term. So this becomes minus 5x here. So now we've got x squared minus 5x. Now we repeat the process. Now we ask ourselves, how many times does x go into 1x squared? Well, x goes into 1x squared 1x times. So that's just plus 1x. And then we say 1x times x plus 1 And then we get again 1x squared plus 1x. Now we must subtract this. So the x squareds disappear, the 1x squareds disappear, so that's good. Minus 5 minus 1 is minus 6, minus 6x. And then we bring down our final term over there, so that's minus 6. And then we ask ourselves again, how many times does x go into negative 6x? Well, negative 6 times. Then we take the negative 6 and we multiply it over here. Now we get negative 6x, negative 6. And we must subtract all of this. And this, of course, gives us a full-blown 0. So there's no remainder, and this is our solution here. So from here we get x plus 1 multiplied by, and then there from the top, x squared plus x minus 6. So it's the same solution, and we should be very happy, because that's, of course, what we were hoping to achieve here. And this was, of course, x plus 3, I suppose, and x minus 2. Okay, so now let's look at the third way of doing it, and this is synthetic division. So x plus 1 was a factor, thus x is equal to negative 1 is the root, or solution. So what we do here is we're going to write negative 1, and then we're going to draw something that's like the upside down version of the long division, or maybe we can even call it what we used to call the short division those years. And now we're going to write the coefficients on the first line. I left space here, so imagine that there's a line there. So I'm going to put all the coefficients of our polynomial. So it's 1 from the x cubed, 2 from x squared, minus 5 from x, and then minus 6. And then what you do over here is the first column in this bottom row, you ignore it. And what you do is you bring down that first coefficient. And that's just 1. Then we take our solution, our root here, minus 1, and we multiply it with that number, and the solution goes in over there. So negative 1 times 1 just gives us negative 1. And then we add the top row and the bottom row. So positive 2 plus negative 1 is positive 1. Now we do the same thing. We take negative 1 times 1 over there, and we put our solution in this column. Negative 1 times 1 is negative 1. And now we add again. We say negative 5 plus negative 1, and this is negative 6. And then we do the same thing. We say negative 1 multiplied by negative 6, and this gives us positive 6. Negative 6 plus positive 6 is 0. So this is the coefficient of x squared. So this gives us 1x squared. And then this guy is the coefficient of x, so that's plus x. And then this last one is just the last term, which is negative 6. Once again, we get exactly the correct answer. So our p of x is equal to x plus 1 multiplied by this quadratic, which is x squared plus x minus 6. And again, for further factorization, it's just x plus 1. And then, of course, here we'll have x plus 3 and x minus 2. So all three methods gave us the correct answer. It's just a matter of which one you like more. And this will be important when we eventually sketch these cubic graphs, because then at least we'll know where the x-intercepts are. Alright, that's it for this one. Thanks guys. Bye-bye.